Can you keep a secret? I have access to the TMUA 2024 paper. This hasn't been released officially. I've accessed it through a secret source, and I thought maybe you guys would want to see it. I'm not sure. Maybe you do, maybe you don't. Here's one of the problems. Let me know if you want to see more. This is from last year's TMUA paper. How many integer solutions, y at least modulus x, and y plus modulus x at most 20? So we want x and y to be integers and satisfy both of these inequalities. Do pause the video now and give this one a go for yourself. I'm going to dive right into a solution. So there's a couple of ways we can approach this. But the way the first way I'm going to approach this, and maybe I'll outline the second way at the end, is just play around with this problem. It's not a standard problem. It's not one that I've seen or of this form, but I don't think this is too difficult to just play around with and get to the answer. So let's just mess around and let's pick a value of x. I think because we're dealing with modulus, let's start with x is 0. So when x is 0, we want y to be at least 0 and y to be at most 20. And so how many solutions are there? So in other words, y has to be bigger than or equal to 0, and less than or equal to 20. Well, there's 21 solutions there. Cool. Nice. Okay. What about, let's change this up. What if x is 1? Well, what do we have here? Well, we need y to be at least 1, and y plus 1 to be less than or equal to 20, so y to be less than or equal to 19. And so therefore, there's 19 solutions there. Cool. If x equals 2, what do we have? We have y must be at least 2, and y must be at most 18. How many solutions are there? Well, there's 17 solutions, and maybe you can kind of spot the pattern. It's going to go down and down and down and down by 2 each time. So if I just fast forward and maybe make x equal to 10, we're going to get y must be at least 10, and y must also be at most 10 as well, and so there's only one solution there. And if you try and make x more than 11, you don't get any solutions because y would have to be more than 11 but less than or equal to 9. Not possible. Cool, so do I just add up 21 plus 19 plus 17 plus 15 and so on? Well, yes, but what we've got to remember here is we've got modulus x, so x needn't be a positive integer. In fact, x could be negative as well. But notice that every instance of x is kind of embedded in a modulus of x. So if x equals 1 gives 19 solutions, then x equals minus 1 would also give the same 19 solutions. Well, the same 19 solutions except x equals minus 1 there. So we're going to get 2 lots of 19 there, 2 lots of 17, 2 lots of 15, 2 lots of 13. Notice I don't do 2 lots of 21 because minus 0 is still 0, but minus 1 is not the same as 1, so those would be genuinely distinct solutions. And so now all I've got to do is add these up. So 21 I'm going to keep to the side for now, but what is this thing here? This is just an arithmetic sum. If I factor out the 2, it's 1 plus 3 plus 5, all the way up to 19, and I'll put the 21 here. And now, just dealing with an arithmetic sum, so it's 2 times. Now, how many terms are there here? Well, the formula for this sequence is 2n minus 1, and so there are 10 terms here. I guess another way to think of it is you went from x equals 1 all the way up to x equals 10. So we've got 10 over 2 times 2 times 1 plus 10 minus 1 times d, and then this is all plus 21 at the end. This 2 and this 2 cancel, and so we're left with 10 times 2 plus 10 times 2 minus 2, so just 10 times 2, and then plus 21. 100 times 2, 200. The answer here is 221. Now, I've got access to all of the 2024 TMUA problems, so if that's something you wanted me to show you some solution videos for, I'm not sure, because I know lots of people are a bit hesitant about seeing recent papers, let me know in the comments down below. Well, as I say, there's another way to kind of approach this. What is that? Maybe you could think about sketching a graph, and I'd highly encourage that. If you've seen my videos before, I love sketching graphs. How else could you approach this? Well, again, it's kind of just noticing that, well, every instance of x is embedded in a modulus. So you might be scared of this modulus, but we don't need to be. We can kind of just get rid of it and just do a little substitution and say, let u equal modulus of x. And so now the question is, y must be at least u, and y plus u must be at most 20. And now you're just solving this kind of set of inequalities. You can sketch this, and you've just got to remember u has to be at least 0, and you've also just got to remember this kind of double counting for any positive values of u. and you get to the answer. Anyway, thanks so much for watching. I'll leave another video on screen where I solve a TMUA style problem from my bank of many, many TMUA style problems, and I'll check it out. I will check it out. You'll check it out, and I'll catch you over there.